Okay, here we go. Now, this is just me telling you, next year when you take, if you take this class, Providence Stats, they will go so deep into statistics that I just want you to know a few things before you get there, and that is this. There's something called a sample and population. There's a difference between the two. I'll give an example. If I said, what's the average height of a student at Central High School, the average height, for me to actually get the perfect answer, the right answer, I would have to do what? I'm going to talk to everybody and say, what's your height? What's your height? What's your height? Then I'd have to add up all 950 of them, and then divide by what? 950, and come up with a perfect answer. And that would be the average height of a Central High School student. Do you think I'm going to do that?
Yeah.
If I really, really wanted the answer, do you think I got to talk to 950 of you?
Around there.
No.
Like, what do you mean by around there? How many?
The deviations.
Oh, I'm sorry, I was looking at the wrong guy. What do you mean? What do you mean? Around there. How
Around
bright?
the mean of all the students.
Why don't you just use sample groups, like take like random classrooms and then
Right. And that's kind of where I was going with that. You guys, population, when you want to grab a bunch of data, population is the entire group of people you're talking about. So if I wanted the average height, of the key word is what? All students at Central High School. That is what? That's what I'm talking about. But there's no way I'm going to go talk to all these people. I'm going to do this. I'm going to go after a sample. What could be a sample?
25.
Okay, let's say you guys, you're 20. Why can't I just talk to you guys and say, I want to take you guys as my sample, and then when I get done with you guys, I come up with an average height of 5'7", and I call that good.
I thought it was wrong.
Is that good?
Yeah.
But then
Can I just say that the average student center is 5'7"?
No, because we are different grade.
You're what?
There are 4 different ages.
Ages here at Central. Freshman and sophomore, junior, seniors, and this group is
But it's all the
mostly
students
what?
at Central.
Upper class. So you guys, you're a sample, but you're an upper class sample, which
We're
means
outliers.
not so much outliers, but in the bell curve. Look at this. Here's the bell curve.
We're probably
You're probably more in the upper half.
13.5.
The freshmen are down here. Sophomores, juniors, seniors. So here's the deal. You'd have to take a very good sample. And a good sample would be go take a junior class, a senior class, a freshman, and a sophomore. Get all 4 of them. And maybe not just do 4, maybe do 6 or 7. So the more samples you do, the better your average gets. So this would be, a sample would just be what? Average height of room 327. You guys. It's not a good sample. I couldn't base the answer over here on you guys. It just wouldn't be fair. I could get close. I could be close, but I think I'd be wrong. Okay. So here's the deal. When you get to Providence Stats, mean standard deviation, you know what that is. The mean for your sample is this. Standard deviation for your sample is S. It's not sigma. When you do samples, standard deviation is S. The mean is X with a bar above. When you talk about the real answer, the average is called mu. It's a Greek letter. It's like sigma and delta and theta. It's mu. Mu stands for what? Average of the real population. Where standard deviation is what? Sigma. Okay? So I want you to hear this stuff because some of you, like I said, will end up in that class. Okay?
So is mean just a lie?
Okay, the mean for the sample, this is the symbol for it. The mean for the population is mu. Okay. It's 2 different symbols, but it's just the mean, it's the mean. Do you understand the difference between a sample and the real population? Yeah? Okay. You know when people say Hillary Clinton will beat Trump, Trump will beat Hillary Clinton?
She did it.
You know, here's the deal. They can't talk to everybody, right? They can't. They got to take samples. So then they call people on the phone or they take surveys. They can only get a sample of the population. How perfect is that?
Is the census is
Apparently
or
not
is the
that
census
great.
everyone, right?
No, the census is everybody has to be answer the questionnaire. That would be everybody has to say something.
Unless they don't.
That would take.
Unless they don't, right. But, you know, when you take a census, you hire people to walk door to door to door. That's a very serious thing, the census. Because if Grand Forks is above 50,000 people or below 50,000 people, it's money. You have to know how many people you have in your city. Because if you're over 50,000, you'll get more money. If you're below 50,000, you get less money. It's all government. I mean,
So they're not extra.
that's totally a different thing though than what I'm talking about. Okay? What's a z-score? That's what you want to know, and that is your answer. That's your answer on the test. Well, the quiz. It's not a test. Here we go.
Are you? Yeah, are you?
Hope you're writing. A z-score. How many standard deviations a data value, any data value is from the mean or average, whatever. How many standard deviations a data value is from the average? Okay?
So you have a z-score of 2 and these two standard.
Yep,
deviations.
exactly. I'll go there right next. Hang on. I got one more thing to say. Z-scores are given as percentiles. Okay? Now, you guys might not have dealt with this much because I asked this question all day. Have your counselors ever said, hey, so-and-so, you fall in the 75th percentile?
Yeah.
You have heard that, right?
No.
Yeah.
Okay, if you have, then you can maybe tell me, but if you haven't, 75th percentile means
You're in the top 25%.
You're above. You're,
that what? Do you know?
You're in the top
Isn't it
25,
like-
right?
you're,
No.
The bottom.
you're,
Yeah.
it's so hard to explain.
Actually, when I write down, I think you'll say the opposite. Go ahead.
Percentile basically means that of the percentage of whatever was like consensus was taken,
Yeah.
your answer was that number in that. Did that make any sense?
Yeah. Well,
Are you the 25% of this? You're the 75% of all.
If you're at
Here's what it is. 75% percentile means.
That means there's 74 other answers in front of yours.
Let me say it this way: 75% of the people in the survey scored
Worse, right?
below you. So if I told you, you took your ACT score, you took your ACT test, and you got in the 75th percentile, that means you scored 75%, scored below you, so you scored 75% below you, so who scored better than you? 25, right?
I said you're in the top 25 percentile. You said that was wrong.
It's not the way you word it though. Because percentile says, it's not the way you word it. Percentile says what scored below you. So when I say 75, you say, well, that means I scored better than 75% of the people in the survey. So if somebody told you at one time, when we talk height, you are in the 85th percentile. In your mind, you're thinking, I'm taller than 85%. I'm taller than 85% of the people out there. Okay. You know what? When you were a little child, 0, 1, 2, 3, your parents took you to the doctor, and
Sorry.
your parents took you to the doctor and they told your parents, you know, your height is 85th percentile, your weight is the 27th percentile. They do all that kind of number crunching to tell your parents about where you fall. That happens all the time. They'll even give you the head circumference. The head is this big, and you know all this stuff. This percentile, so you can compare yourself with the whole population. Okay, but that's all a z-score is. It's a percentile. It also says how many standard deviations you are away from the average. So now, before I go here, I want to go here. Next slide. Would you quick do this? Make yourself a bell curve. Okay. Okay, and then go like this, right in the middle. Put the average, and then there, then here, then here, 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 here. Okay. Now I want you to tell me, where is a z-score of 0?
To the left.
Z-score is what?
The percentile.
Z-score of 0.
Middle. In the middle.
It's, yeah, isn't a z-score how far you are away from the mean? If your z-score is 0, you are the mean. You are the average. Woo. Okay, what's a z-score of 1?
Right?
1 standard deviation away from the average, right here. A z-score of 2, a z-score of 3. Remember these numbers, 1, 2, 3. All they say to you is, I'm 3 standard deviations from the mean. I'm 2. I'm 1. A -1 would be here. A -2 would be here, and a -3 would be here. How many standard deviations away from the mean are you? So now, where is 0.34 z-score? 0.34. Start here.
Right there.
Right there? Okay. So now, this is kind of what I'm going to ask you to estimate the percentile. But before I ask you to do that, is your hand up?
Yeah.
Oh, what is it?
So when you say percentile, that means everything below you.
Yes, everything below.
So percent is where you are above, right? So if you're talking,
Well, if you're thinking,
if you're
I'm in the top 25 like you said, yes, you're right. But the definition of percentile is what's below
So
you.
if you say like I'm in the top 25%,
Then you're
in
at
the
the
top
70.
fourth. But if you say 75th or 25th percentile, you're in the
Oh,
bottom.
now you're in the bottom. Yeah, don't say it that
So
way.
percent means up.
Okay, yep.
Thanks.
Here we go. Now, let me talk to you about this. If you have a z-score of 0, if your z-score is 0, what's your percentile? What scored below you?
50.
50%, thank you. Okay, then, if I say a z-score of 1, what scored below you?
Oh. 84.
How'd you get 84?
34% is up there.
He adds 34. He said 1 standard deviation over. He added the 34 to the 50, and he got 84. Okay, he's right. Okay, what if your z-score is 2? What's your percentile?
95.
It would be 50% right here, plus the 34, plus 13.5. What's that? Plus 13.5 right here. Add this piece onto that piece.
7.
Right? A z-score of 2, you are in the 97.5 percentile. Which means you did better than 97% of the people. Okay, if you have a z-score of 3, what's your percentile now? 99.7.
0.7.
No.
6.5.
No. At
3.5.
6.5 did you say?
Yeah.
Did you say 6.5?
Yeah.
Add 0.35. No.
Oh.
Wouldn't it be 8.5?
Yep.
8.5. 2.35 added onto that would be 99.85. Okay. So you know, you guys, mentally you can come up with these numbers, but we don't want to do that. If I go backwards, anybody know this one?
16.
Say it again.
16.
16%. Good. And probably what you did is you took your 50. Didn't you just subtract off the 34 in here? Yeah, to get that? Is that what you did?
Yes.
Okay. How about this one, -2? 2.5? Because,
You subtract 13.5.
You did 50 minus this, minus 13.5, okay. Or you might have known that this and this together make 2.5. So if you're at a z-score of -3, you scored better than what? 0.15%. Okay. Now, those are probably the only numbers you could have possibly came up with on your own. Here's the deal. What if you have a z-score of this? Z-score equals this. Well, now you're going to need the help of a table. So let's go back here. Let's go over here. And they put a table down here for us. So let's say this z-score is what? 0.34.
We don't have that too.
You don't have that table? In your notes?
Oh, that's back
Go,
to
sorry, go backwards a slide. Yep. Go back. Okay. All right. Now look at this number 0.34. What you need to concentrate on is this. The first digit is 3, and that is your tenths. Second digit is what? 4 is your hundredths. When you read the table, read it like this. These are your tenths. So you'd say 0.3 right here. And then you have 4 in your hundredth spots, so you go to 0.04. So this number and this number together, they make 0.34 when you add them together.
Are we gonna need to go lower than 0.4?
No. Oh, you mean like thousands?
No, like 0.5.
Well, 0.05 is right there.
No, not 0.0 on the other side.
On the 10 side,
Yeah.
is it ever gonna go past 0.4?
Oh yeah. I got tables for you. This is just a little piece of the table.
Oh.
So here we go, down. I'd go with this is your answer for the percentile. So when you look at that number, 0.6331, it's a percentage. What percentage does that stand for? 6 what? 63, sorry, 63.31%. So if your z-score is 0.34, you score better than 63% of the population. Okay? And it should kind of make sense because at the halfway mark, that's 50%. If you keep going, a little more, you're going to go up, up, up. Here we went to what? 63.
If that's your middles, your bell curve can come down.
No, don't look at that as a bell curve because really, one standard deviation, this isn't even close to 1. 1 would be way out here. This is not drawn to scale. Do not look at that scale. Because really, to be honest, if this was 1 standard deviation, 0.34 would have been here. You know what I'm saying?
So,
Don't, hey, that's not drawn to scale. That's what's messing you up.
no, I'm not like confused. I'm just asking like, so if z or whatever, like the middle point, if that's equal to a number, does that like skew the data? Do you get what I'm saying?
No, I don't get what you're saying. Z-scores are simply just numbers that tell you how many standard
Will the
deviations.
median of the z-score always be 0?
Well, what?
The median of the z-score always be 0.
The median. Oh, you mean the mean? Yes, the mean is always going to be 0. Yes. The average is 0.
Where does this mu thing come in?
Mu is the average of the population. That's all it is.
We haven't even.
Okay, Tyler, if you weren't in the bathroom, it would have made more sense. You came in right in the middle. All right, here we go. We already did this one. This one is roughly
Learned that?
63.31%. Okay? This one makes more sense because I actually drew the standard deviations. Okay? All right?
So we don't have to add what we just got to anything. Like, that is the answer.
That is the answer.
Okay.
All you're looking for is what percentile is the z-score stand for. That's all you're looking for.
Will the tables be provided on the test?
The table's right here. You're going to get them now. So now we want to calculate z-scores. Here is a table. You can't lose it till June. June you can lose it, but not till June.
Well, I'll lose it before June.
You'll have to figure out your z-scores by yourself.
I know that.
Okay, do the first one in the next slide. Yep.
Horrible.
All right. You want to calculate how much data lies
The backside just like
below a z-score of 1. Now, because it's positive, there's a positive z-score side and a negative z-score side. The positive z-score side is pretty obvious when you look at the bell curve. It's the side that's shaded above the average, where the other side shaded below the average, or the other side's negative. Here's what I would do. I would take the score of 1, and I'd write it like this. Z-score equals 1.00. You want it always to be to the nearest 100. Then you go look at your table. In your table, go find the tenths column. Your tenths are right here. 1.0. So you go look for 1.0. And in your hundredths column, what's in the hundredths column? 0. So you'll go 0.00. So look this way, look this way. You get point what?
84.13.
Okay. Now, isn't it weird that we said just a little bit ago that a z-score of 1 is 84%? This is 84.13. Here's what happened. They made these numbers back here, they made them really easy for you. They rounded to the nearest number to make it easier for you to do in your head. You can add these numbers so quick in your head. The true answer for a z-score of 1 is not 84, but what?
84.13.
There you go. How much of the data fall below? 84.13 are below. Okay, there you go. You have to say are below or are above. They're going to ask you how many above or below. So you got to be careful with this. Okay, the next one is, I got positive 2.8. Do you have negative? Will you change yours to positive? Change yours to positive 2.8. Okay, look up the z-score for positive 2.8. Change it to 2.80 though. Okay, hang on there. What's the number? 99 what? 74. Okay. We want to know what? How much is below? Well, below. This is below. Z-scores are below. So you're going to say what? Are what? Below. Good. How much data lies what? Is the next question. Above. This is where it gets a little tricky on us. Be careful with above. Okay.
Do you want us to change it to positive?
No, this one it's negative 1.47. So I'm looking at the negative 1.4. You gotta flip your yellow sheet though, guys. Get on the negative side. Okay. Go this way, go that way. You're getting what? Point what?
0.0708.
707.
08.
Okay. Now you got to realize what just happened here. They asked you to find the percent. How much data falls above this? You got to understand where you're at. Where are you at on this bell curve? If this is 0, negative 1.47 is where? Right here. Okay. Well, what's above? You're looking for this, everybody, right? Do you understand?
92.9.
Yeah, so what are you going to do?
Subtract that number from 100.
Yeah, take all of the data, all of it 100%, take off what you already know down here. This is what you know, 7%,
7.08.
equals 92.92%. Fall where?
Above.
Above. Okay. Yeah? Okay. Last question. How much data falls where?
Above.
Careful with above. Above messes you up because the data, sorry, the yellow worksheet says below. It doesn't say above. Answer?
3.39%.
How much?
3.39%. Oh, that? Just
Yeah.
kidding. That's 0.9961.
9961. Okay. And that's what falls where?
Below.
Below. 99%, actually 99.61% is below. And if I drew you that picture again, here's your picture. A 2.6 is right here, roughly. There's your average. Okay. And what we want is above. So our answer is very small. Okay. So you take 100% of the data. You take off this back side, right? 99.61. What's the answer?
3.39.
3%?
No, it's point.
Isn't it point?
Oh,
39.
just kidding.
Oh, just 0.39, right?
Sorry. I tried.
What about 0.39?
It is how much is above.
How much above, right?
Just all 100% in this.
We'll see. Turn page. Now they go more into story props. Okay? Read the story, please. Oh, I'm sorry. Nope. Sorry. Now we gotta learn a quick little formula. I forgot. A quick formula on how to get a z-score. Z-scores will be, okay, it will be x minus, x is what? Any data. You're given some data, plug it in. So your data minus the average of your population, which Tyler is mu, over what? Standard deviation. So it's just three numbers, you plug it in, you work it out, you get your z-score. 2.41, whatever. Okay, here we go. We're going to calculate some z-scores. In a given population, the data is normally distributed over the mean of 35. Once they start giving you some information, you might as well start putting numbers down. The average of the population is 35. Standard deviation is what? 2.8. Okay. How many standard deviations away is 42? Well, calculate the z-score because that's what a z-score tells us. How many standard deviations away from the mean? So what is the z-score on a 42? What are you going to plug in? Yeah, which ones?
42,
42 minus
35,
35 over
2.8.
crunch it. To the nearest hundredth, what's the answer?
2.5.
Okay, I heard you say 2.5. Give me one more number after that.
That's all.
Yeah, it's just 0. Okay. So your z-score is 2.5. Is that really a high percentile or low? It's what? Guys, where does 2.5 fall on the bell curve? Here's z-score is 0 right here.
Oh, high.
You're way out here at 2.5. Yeah, you scored a lot better than a lot of people. Huh?
99.38.
Well, yeah, I'm not worried about it. I just wanted you to say hi.
Sure.
Hi. Okay, go. Do 32. I think you have 11, don't you?
Yep.
Yep. Do 32 instead. Nothing but putting in numbers. Eric, what'd you get?
Not finished yet.
Okay. Aaron, what'd you get?
Negative 1.07.
Okay, there it is, right there. And if you think about where you fell when it comes to the population, you fell where? On the low end, guys. You did not. If we took a test, you didn't score better than many people. Okay.
32.
Good? I'm not asking you to find the percentiles, not yet. Are you okay with just finding z-scores?
Yes.
Next slide down, here we go. Now the story probably comes. In a given population, the weights of newborns are normally distributed about the mean. What's the mean?
32.
3,250 grams for a newborn. That's the average. Standard deviation of the population is 500 kilograms.
Oh boy,
What do you think about that?
that's hard.
Big boy.
First of all, kilogram, that's 1,000 pounds, guys. Get rid of the K, just grams. I don't think that would be the standard deviation. That's a long ways away from the mean. Okay, so you have this. Average, 3250. Whoops, 3250. Standard deviation, 500. Okay, here we go. What is the z-score of a newborn weighing 2,500 grams? Z-score, 2,500. Just do what we did on top. Taylor, you got it? Oh, okay. That's not fun.
Rookie mistake.
Here, you gotta try some of this. Okay? Alright, Adrian, you got it?
Yes, sir.
What is it?
The percent or
No, just the score.
negative 1.5.
Okay, z-score, negative 1.5. Okay, that was the first question. What's the z-score? Got it. Actually, I should have said negative 1.5 what?
0.
0. Okay. Then, the next question. What percent of the babies are beneath that child? Well, look this up. What'd you get?
6.68.
6.68. Okay. And since you saw that number, you should be thinking, oh, that's below. It's always below. Okay, and that's what they wanted, right? Beneath. So 6.68% of newborns fall where?
Well,
Fall below. Okay? Now, when they use the word below or beneath, that table is giving you the answer. When they use the word above, that's the tricky one. Okay? All right, do this one, and notice the word above appears. What's the z-score of a newborn baby weighing 4,500? Here, you got it?
No.
Okay.
That's smart.
Elizabeth, you have it? Just the score.
2.50.
2.50. Did you get positive or?
Positive.
Okay. She gets positive 2.50. Do you guys get that? Okay, that's good. So you look that up, and whatever you see is what's beneath or below that baby. So what does this calculate into percentile? 99.38. Okay, scored what? Or weigh what? Below that baby. The question is, what percent of the babies are above? Way more.
100 minus 99.3.
Yeah.
0.62%.
100%. Take away the ones that are weighing less, 99.38. You get what?
0.62.
Okay, here it comes. 0.62% weigh what? Above what kind of baby? A 4,500 gram baby. Okay.
How is that?
2,000 grams is 2,000 grams is 2 kilograms. 2 kilograms is about. So it's like 2 pounds. It's a 2 pound, 2.5 pound baby. These are newborn babies. Newborn babies are born.
6 pounds.
7.
No, the rule for a newborn isn't it 6 weeks before the due date? Isn't that what a newborn is?
What?
The definition of a newborn baby. Isn't it? If the baby's
That's
born.
premature.
Yeah, that's
Yeah.
No, but
I
meaning like.
I'll let that.
Am I thinking premature babies? I am. Okay, that's fine. That doesn't make sense though. 4,500 grams. Okay. 4,500.
I was above the.
1 kilogram. Here, 1 kilogram is 2.2. This is an 8 pound baby. Sorry, this is 8.
Okay, that makes sense.
That makes more sense. Yeah. Okay. Next question.
Dude, I was
I'm like
6.2%.
Yes, it's over here. What is the probability that a newborn baby weighs between 2270 and 4330? Hey, do me a favor. You guys do z-scores for 2270. You guys do z-scores for 4230.
62 now. 62 and 185.
Okay.
62, 185.
I'm saying like 5.
62, 185. I'm saying, you know, it's
Okay. This side of the room, 2270 is what?
0.06, negative 1.2.
Is that negative?
Yeah.
1.96?
Yeah.
Okay. That side of the room, 4230 is what?
1.96.
Oh, okay. Now, here's the deal. You want the probability that a newborn weighs between this and that. You guys think of this as your bell curve, right? In your bell curve, here's the z-score is 0. A 196 would be here, and a negative 196 would be here. Tell me the percentile for 1.96. What did 1.96 for percentile come up?
Oh,
90?
97.50.
97.50 fall where? Below. Okay, what's negative 1.96?
2.5.
2.5%. Okay, so I want basically everything from this line back to that line.
Would you just subtract them?
Because what you're really saying is 97.5 all the way this way, but you just want to take off that little tail. That tail is 2.5%. So when you subtract this from this, that minus that is what? 95% weigh what?
In between.
Weigh between 2270 grams and 4230. 4230 grams. Okay. Okay, the next one I'm not going to do because it's the same thing. I'm just going to tell you this.
It's harder.
No, it's not. It's just I just want to tell you the answer. This is what you should get. Try it. The next slide we will do tomorrow. You will be fine. You should be fine on this whole thing. Did you tell your class to take out a sheet of paper on this? This kind of crowded?
No, I
It
just
isn't?
assume they figure things out, I don't know.
Yeah.
I don't know.
Where am I Do you assume that? Well, of course. You didn't ask me what it was. though.
Battery.
That's what those ones do. I went for.
Yeah, but I'd rather do that than my
Yeah.
phone spider web until I drop it on my couch.
So tomorrow is just a work day?
Tomorrow's pretty much your day.
Actually, I sat down, I was wearing like joggers, I had my phone.
Well, I want to.
I bent over to have my shoe and my phone for hours.
They're there.
Oh, yeah, where's she then? Oh, okay. So, can you explain it for us?
Yeah, she won't take the time.
Yeah. All right.
I have two.